start with section B. So in this case, question number 15 says find the oxidizing agent in the following chemical reaction. So oxidizing agent is the one which has oxygen with it, and it will help in oxygenating other one. So in this, oxidizing agent is always present on the reactant side and has oxygen with it. So in the first one it is Pb8O4, in the second one it is oxygen, in the third one it is copper sulfate, in the fourth one it is vanadium oxide, then it is H2O in the E part of it, then in F it is copper oxide. So oxidizing agent, remember, has oxygen with it and carries oxygen with it and is on the reactant side. So moving on to next. Question number 16, it says an ore on treatment with dilute hydrochloric acid gives the rotten egg smell. What type of ore is this? How can the metal be obtained from its concentrated ore? So the ore is H2S, that is hydrogen sulfide. It is a sulfide ore, and ore on treatment with HCl gives the smell of a rotten egg. So the gas evolved here is hydrogen sulfide, which is of rotten egg smell, type of rotten egg smell. Then the second is this type of ore can be obtained with the help of roasting and by calcination. So you can write the equation for it in this question. Now question number 17, there is a or part of it as well. For 16th question, it says a boy treated a lustrous divalent element M with sodium hydroxide. So he reacted M with sodium hydroxide and it will form sodium metal oxide plus hydrogen gas is released. He observed the formation of bubbles in a reaction mixture. He made the same observation when the element was treated with HCl. Suggest how he can identify the produced gas. So it must be hydrogen gas, because as it says that it forms bubbles in a reaction mixture. So it could be hydrogen, and we can bring burning splinter near the mouth of the vessel to find out whether it creates pop sound or not. And then write chemical equation for both. So these are the chemical equations for both the reactions. Now moving on to question number 17, it says list 3 limitation of Newland's law of octaves. So in this Newland's law of octave, it does not extend it beyond calcium. It could be valid only till calcium. Now the second is that it assumes that only 56 elements are present there. There are no, like, he only thought that there could be only 56 elements. There couldn't be any more elements in future. So he didn't care about those. Then C part, unlike elements were adjusted under the same slot, like the adjustment of hydrogen with fluorine and chlorine on the basis of their chemical properties. He couldn't justify the, like, how he adjusted this. So that's the 3 limitation of Newland's law of octave. Now moving on to question number 18, we need to difference between the transport of materials in xylem, so xylem and phloem. So xylem transport water and minerals, whereas phloem transport food from leaves to the root to other parts. In the process of xylem, we have transpiration. Transpiration pull is there because it talks about water. Then in the case of phloem, we have translocation, we have osmotic pressure, and expenditure of ATP energy plays a major role in this. And now moving on to next difference is that they are unidirectional, like transport of water and minerals is only from down to upward, whereas bidirectional, phloem is bidirectional because translocation of food occurs both in the upward direction as well as in the downward direction. So this is the main second point of xylem and phloem. So in xylem and phloem you can write these 3 points. Then moving on to next, explain the mechanism of photosynthesis. So in photosynthesis, we need raw materials as sunlight, chloroplast, carbon dioxide and water. Next is energy is needed in the form of chemical energy and also known as ATP, and sunlight helps in splitting water molecules into hydrogen and oxygen. So this oxygen escapes into the atmosphere. Now hydrogen uses the chemical energy to reduce carbon dioxide to glucose, and thus carbohydrates are formed inside the leaf. Now moving on to question number 20. It says, is it possible that a trait is inherited but may not be expressed? Give a suitable example to justify this statement. So yes, it is possible. Like when we take a pure tall pea plant is crossed with a pure dwarf pea plant, only tall pea plants were there in F1 generation, but on selfing F1 plants, both tall and dwarf plants are obtained in F2 generation, that is in the ratio of 3:1. So reappearance of the dwarf character in F2 generation shows that it was inherited but it was not expressed in F1 generation. Now moving on to next, it says describe any three methods of tracing evolutionary relationship among organisms. So there are three, that is homologous organ, define them, give one example, then analogous organs, define them again, give examples, then the third one is fossils. Fossils help in finding out the evidence of species that were no longer and how we are connected with them. In the next one, question number 21, it says if the image formed by a mirror for all the positions of an object placed in front of it is always erect and diminished, what kind of mirror it is? Draw a ray diagram to justify your answer. Where and why do we usually use this kind of mirror? So it is convex mirror or the diverging mirror. Then in that you can draw this ray diagram where image appears to be behind the mirror and erect, diminished and virtual image is formed. So it is convex mirror. Now you can, in the third part it says write the uses of convex mirror. So convex mirror is used in rear view mirror in vehicles, malls, hotels and airports for security reasons because it has a wider field of view. Now next one, how will you infer with the help of an experiment that the same current flows through every part of the circuit containing three resistors in series connected to a battery? So in this, draw resistance 1, resistance 2 and resistance 3 and an emitter here to find out the current and a battery and a key. So plug the key in and note the emitter reading. Change the position of the emitter to any place between any resistor. Like you can first keep it here and measure the current. Then you can keep this emitter here by changing the position of it, like to measure. Then you can keep it here to check the emitter value, and you will find out that the emitter will show the same value throughout the connection because it cannot be affected, the current cannot be affected in series circuit. Now next one, question number 23, it says draw a diagram of an electric circuit containing a cell, key, emitter, a resistor of 2 ohm in series with a combination of 2 resistors 4 ohm each in parallel and a voltmeter across the parallel combination. Will the potential difference across the 2 ohm resistor be the same as that across the parallel combination of 4 ohm resistor? So in this, as you can see, there are 2 resistors which are in parallel. Then 2 ohm is in series with these parallel resistors. Emitter is there, key is there, switch is there, and with respect to resistor we have a voltmeter to measure potential difference. Now the question is, will the potential difference across the 2 ohm resistor be same as that across the parallel combination? So yes, the potential difference across 2 ohm resistor will be same as in the case of 2 resistors of 4 ohm, because this is because the 2 ohm resistor and parallel combination of two 4 ohm resistor are connected in series, and if they are connected in series, that means they will have same potential difference. Now moving on to next or part of it, it says three resistors R1, R2, R3 are connected in parallel, and we need to draw battery, ammeter, voltmeter and key. Draw the circuit diagram, obtain an expression for the effective resistance of the combination of resistors in parallel. So make the circuit like this as shown in screen. So they must be in parallel, and with respect to them make a voltmeter around it and ammeter in series, then make a switch, make a battery around it. Now we need to obtain an expression of effective resistance. So first of all, I1 plus I2 plus I3 equals V over R. That means total voltage over total resistance. Now I1 will be V over R1, I2 will be V over R2, I3 will be V over R3. So putting all the values into equation 1, you get V over R equal V, taking V common from the right hand side. Then we have 1 over R1 plus 1 over R2 plus 1 over R3, and cutting down the value of V and V on both the sides, we get 1 over R equivalent is equal to 1 over R1 plus R2 plus 1 over R3. Now moving on to next, out of the given food chain A, B and C, which one has the minimum number of trophic level? If in each food chain the same amount of energy is available to the plants, in which case will the organism at top of the food chain get minimum energy for survival? So for the answer 1, it says minimum number of trophic level. So as you can see in figure A, we have only 3 trophic level. So it will be in the case of A. Now it says if in each food chain the same amount is available to the plants, in which case will the organism at the top of the food chain get minimum energy. So as you know that as we move up the group, so there is a decrease of 10%, there is a change of 10%. So as you can see in B part, we have 5 trophic level. So if we have 5 trophic level, therefore there will be 5 times decrease in the 10%. So the least energy available is in the B part. So that's the end for section B. I will continue with section C in next video.